Hello, today I'm going to do example 1 from section 9-2, part 1. The results of a state mathematics test for random samples of students taught by two different teachers at the same school are shown in the table below. Can you conclude that there is a difference in the mean mathematics test scores for the students of the two teachers? Use alpha equals 0.10 and assume the populations are normally distributed and that the population variances are not equal. So since we're comparing two averages or two means, this is either going to be a two sample t-test or a two sample z-test. And since it says the population variances are not equal, that indicates that we don't know what they are, but we're going to assume they're not equal, which gives us the two sample t-test. So we need simple random samples, which I'm going to assume they were. We need normally distributed or n greater than 30 for both samples. Well, both are assumed to be normally distributed, and variances must be unknown. So we can conduct a two sample t-test. Next, identify the hypotheses. And we want to conclude, is there a difference? So that means mu1 not equal to mu2. And that would be our claim. So then our null would be mu1 equal to mu2. Since this is a t-test, this will be a t-distribution. And since the alternative is not equal to, it's a two-tailed test with 0.05 in each tail. Next, we need to do the test statistic. So we're going to plug these values in to the calculator. So we go to test T2S. First, I want to do a two-tailed test, so F1. X bar 1 is 473. Standard deviation 1 is 39.7. And 1 is 8. X bar 2 is 459. Standard deviation 2 is 24.5. And N2 is 18. As I mentioned in class, we're going to leave pooled as off or false, depending on your calculator, for this class. And we know it's not pooled because we're assuming the populations are not equal. And we get a t-test statistic of 0.92. Now, instead of reading off the p-value, I am going to find the critical values. In order to find the critical values, though, I do need the degrees of freedom. And remember, for a two-sample t-test, the degrees of freedom is more complicated, but the calculator gives it to us. It's approximately 9.5. So now I'm going to calculate this critical value first. So that'll be inverse t. Need the area to the right for a Casio calculator. So the area to the right is 0.95. If you're using a TI calculator, you still need the area to the left. And then we need the degrees of freedom. So if we go here, distribution t, inverse t, 0.95 is already in there. Oh, and it already puts the degrees of freedom in for us. Good. And hit execute. Took it a little bit, but we get about negative 1.82. Next, I want this critical value. But because of the symmetry of a t-distribution, I know it's just going to be positive 1.82. Our test statistic is 0.92, which falls about right there. So since T star is not in the rejection region, we fail to reject the null hypothesis. And since our claim was the alternative hypothesis, there is not enough evidence to support the claim that there is a difference in math test scores between the two teachers. And that is it for example 1.